for 4.5 today. Quick, upcoming events. That means 4.5 homework will be due Monday. Monday we'll start 4.5 review. And then what I've opted to do is I have the Chapter 4 test scheduled on Thursday. Okay? I can't do Friday because of the Christmas program. And then if I push it to Monday, then you guys only get 2 days of final exam review. And I realized in the past I've done 3 days. So I went with that route. So test will be next Thursday, which is normal timing. I was just trying to give us a little extra time, and it didn't happen. So, okay. We talked about example A just a little bit yesterday. And it relates to the ones we did on the front side, which the whole deal is when you see fractions, we want to get rid of them. We don't want to work with fractions. What was the first thing I would suggest you guys do on this one? Yeah. We have a denominator of x minus 5, x minus 3, and then we have this other denominator that, if you're any type of algebra student at all, you've realized it looks like it probably factors, doesn't it? So if we factor this, x squared is x and x, multiplying to be 15 is 5 and 3, multiplying to be positive and adding to be negative 8 is x minus 5 and x minus 3. Okay, guys. I'm going to go with 99% of the time. If you have to factor, it's going to factor into other things you already have. Okay? Now, let's talk least common denominator. Because that's what we're going to use to multiply. What are the pieces of the denominator that are in common? What's in common here for my denominators? There's an x minus 5 in common? What else is in common?
X minus 3.
X minus 3.
I was about to say there's nothing in common, but like...
There's factors of x minus 5 and x minus 3. We got everything in common. Are there any leftover pieces? No. So my least common denominator is x minus 5 and x minus 3. And what that means is I'm going to take x minus 5 and x minus 3, and I'm going to multiply both sides of my equation by x minus 5 and x minus 3. What I do on the left, I do on the right. The idea, realize, is that x minus 5, x minus 3 is going to multiply by each term. So on the left, x minus 5, x minus 3 multiplies by 1 over x minus 5, and it multiplies by x over x minus 3. On the right, it multiplies by this one fraction. I'm going to kind of write this out the long way as we learn. As you feel more comfortable, you can probably skip this writing out step I'm getting ready to do. But it's kind of, I feel like a teaching way. So I'm going to take my original equation, and I'm going to kind of space it out. So I'm going to leave room in front of my 1 over x minus 5 to show what I'm multiplying by. Plus, I'm going to leave a gap. So I can leave room in front of x over x minus 3 to show what I'm multiplying by. Equals. And on the right side, I'll go ahead and write 2 over x minus 5, x minus 3. But then I have room to write, what am I multiplying by? So what am I multiplying each of these pieces by? I'm multiplying each of these pieces by x minus 5, x minus 3. So 1 over x minus 5 gets multiplied. Then I'm multiplying the next one. X over x minus 3 gets multiplied by x minus 5, x minus 3. And on the right side, the 2 over x minus 5, x minus 3 gets multiplied by x minus 5, x minus 3. I'm doing this for the visual. Now, looks kind of funny the way I have it written, but what do you guys know about x minus 5, x minus 3? How do I make that a fraction? Yeah, all of these are over 1. So that means in every scenario, I'm multiplying a fraction times a fraction. Okay, you ready? First pair of fractions that we're multiplying. What cancels? X minus 5 on top cancels with x minus 5 on bottom. What remains?
X minus 3.
X minus 3 times 1 divided by 1, whatever. It's just x minus 3.
Yeah.
Plus. Repeat the process. X minus 5, x minus 3 times x over x minus 3. What cancels?
X minus 3.
X minus 3 cancels with x minus 3. What remains?
X minus 5.
And?
1. X still.
X minus 5 times x?
Yes.
Or I'm actually going to write it as x times x minus 5. I'll do the next part in the next step, if I heard you correctly there. And on the right, 2 over x minus 5, x minus 3 times x minus 5, x minus 3. What happens?
Just 2.
X minus 5 cancels, x minus 3 cancel, and you're left with 2. And now we have an equation that doesn't have fractions. Okay. What do?
Combine like terms. Okay.
Pause that thought. I don't want to combine like terms quite yet. What do I need to do with x and x minus 5?
Distribute. Yeah.
Yeah, let's multiply, let's distribute. So I'm going to have x minus 3 plus x times x is x squared. X times minus 5
5x. Negative.
minus 5x equals 2. Okay. This is an algebra equation that you know how to solve. You've done anything in my class this year, right? What do you think we need to do?
Now combine like terms.
Okay, combine like terms. What like terms are we combining?
X minus 5x.
Okay, x and minus 5x. I'm going to put the x squared out front. X minus 5x is
Minus 4.
minus 4x. Then what do you want me to say?
Add 3 subtract the 2.
Yeah. Could we go ahead and move that 2 over? You guys see where this is going? This is going to be a quadratic, right? There's x squared, there's x's, there's numbers. We're going to want, since it's a quadratic, we're going to want this equation equal to 0. So I would go ahead and say subtract the 2 over. The 2 is going to subtract from the negative 3. What's negative 3 minus 2? Negative 5. So kind of 2 steps in one there, but then you have x squared minus 4x minus 5 equals 0. What do?
Factor.
Factor. Yes. 2 parentheses. X squared is x times x. What's multiplying to be 5?
Negative 5 and 1.
Okay. I wrote 1 and 5. She's telling me negative 5, positive 1. That would multiply to be negative 5 and add to be negative 4. Am I done?
Nope.
No? Now what?
Set them in equal to 0.
Set each factor equal to 0. So x plus 1 equals 0. X minus 5 equals 0. What do we get as answers?
Negative 1 and 5.
X equals negative 1. X equals 5.
Is 5 extreme? Because it's still not.
So don't forget, we are asked to check for extraneous solutions, yes? So your last step in every problem is just do a quick check. Do they work? And as we look back at our original 2 denominators here, what would our restrictions say? Restrictions would say that x can't equal 5 and can't equal 3. What did I just get as an answer?
5.
5. So guess what? 5 doesn't work. Because 5 right here, 5 minus 5 would make that denominator 0. So that's how I know it doesn't work. Would negative 1 make my denominator 0? No. So, I mean, technically we should check it, but it should work. As long as it doesn't make the denominator equal 0. The only way it's not going to work is if you made a mistake somewhere. Okay? Okay, questions? That's the basic gist of what we're doing.
So how is that, like, mathematically speaking, that we can get 5 as an answer if it doesn't actually work?
When we multiplied by x minus 5, x minus 3, and brought those pieces out of the denominator, we created those extra answers, is what happened. Because we took an equation that wasn't necessarily a quadratic equation, but we turned it into a quadratic equation to clear our fractions.
Okay.
Okay, so when we took it and we created that extra answer in the process is what happens. If that makes any sense. But yeah, we took a non-quadratic equation, turned it into a quadratic equation to solve it, which helps because it gives us the answer we need, but it gives us an extra answer along the way.
Okay.
So, okay guys, there's the gist of what we're doing. Let's look at some of the other twists and turns here. B. 3 over x minus 3 equals x over x minus 3 minus x over 4. Any thoughts on what we should use as the least common denominator? Now, if you're not sure, I'm going to take you through the questions of what's in common. So there's x minus 3 in 2 places, yes? Any other leftovers? So my least common denominator is 4 times x minus 3. Or x minus 3 times 4. Okay. What am I going to do with that 4 times x minus 3?
Multiply it.
We're going to multiply both sides of the equation by 4 and x minus 3. Yeah, I don't have room right there. Okay. Now, I'm going to continue to do what I did on my last one, where I'm going to write out the original problem. And I'm going to put the 4x minus 3 by each spot. As I said earlier, do you have to do that? No. If I do this for me in my head, I do the canceling in my head. But I use the visual approach when I'm working with you guys. So on the left, I'm going to have the 3 over x minus 3. It's going to be multiplied. Equals on the right. And the x over x minus 3, it's going to be multiplied. Minus, and then I'm going to have the x over 4, and it's going to be multiplied. So basically I took the original equation, kind of spread it out. In front of each term, I'm going to put 4 times x minus 3. 4 times x minus 3. 4 times x minus 3. And what do you know about all those 4 times x minus 3's? Put them over 1s to make them fractions. Okay. Now what? 4 times x minus 3 over 1 times 3 over x minus 3. What cancels? X minus 3 cancels with x minus 3, leaving me with 4 times 3, which is 12. On the right, what cancels? X minus 3 cancels with x minus 3, leaving me with 4 times x, or in other words, 4x. Minus, note that next one is a minus. What cancels?
4.
4 cancels with 4, leaving me with what pieces? An x and an x minus 3. And like he said, I like to put the x first, just because what's my next step going to be? We're going to have to take that x and we're going to have to distribute. Okay, so rewrite. I have 12 equals 4x. Now, do you see how this is written? We set it up to distribute x. What kind of x is this set up to be? Because it was a minus, I'm going to treat this as a negative x or a minus x when I distribute it. Okay, so minus x times x is going to be minus x squared. Minus x times minus 3 is plus 3x. Okay. You tell me, what would you like to do? Okay, combine like terms. So I'm going to say 12 is equal to negative x squared plus 7x. 4x plus 3x is 7x. Now where would you like to go with this? Okay.
I would add over the negative x squared and subtract over the 7x, so your x is covered.
Okay. So two options. Could we subtract the 12 over? Yes. And I'm fine with that. You can subtract 12 over, but then what am I going to say before we do the next step? Multiply or divide everything by negative 1 because I'm not going to want a negative x squared with my next step. What's the other option if you don't want to do what we just suggested? Could you add the x squared over and subtract the 7x over? You can. Does it matter which way you go about this? No. As long as the goal is you need to go end up with a positive x squared before you factor. Fair enough? So, I personally have been adding x squared and subtracting 7x. Again, doesn't matter which way you do this. One way or the other, what are you coming up with?
X squared minus 7x and then plus 12.
Okay. After it's all said and done, x squared minus 7x plus 12 equals 0, yes? And I feel like saying same old, yes? Factor. Okay, what are we getting?
X and x, and then negative 3, negative 4.
Okay, x and x. 3 times 4 is 12. 3 plus 4 is 7. Make them both negatives to get the sign to work. Am I done? Not done. We've got to set each factor equal to 0. What do we get as answers?
3 and 4.
X equals 3 and 4.
Extraneous
I was about to say that.
Okay. What's the issue?
3 at the bottom and then 3 in the denominator.
3 minus 3. 3 would be a restriction, wouldn't it? We can't have 3. X cannot equal 3 because 3 minus 3 would be 0 in the denominator. What about 4? It's okay. Okay? This denominator up here, and I'm bringing this up just because my morning class questioned it. I had a lot of my morning class said, oh, 4 doesn't work either. It does. This isn't x minus 4. This is just 4. So the 4 is okay. Okay? Making progress on how to do these. Okay. C is a good example to talk about because there's a piece there that is not a fraction. So we're going to talk about that. 5x over x minus 2 equals 7 plus 10 over x minus 2. Okay.
You just make it 7 and 1.
You can think of it that way. I honestly wouldn't even make it a fraction, but I'll talk about that here in a moment. So, least common denominator. The only denominator is x minus 2. So what are we going to do to both sides? We're going to multiply both sides by x minus 2. Okay, so we're going to have 5x over x minus 2, and I'll multiply that. We're going to have 7 and the x minus 2, plus I'm going to have the 10 over x minus 2. Okay, I left space next to each piece to write in an x minus 2. So when I multiply x minus 2 times this fraction, I'm going to make it x minus 2 over 1. Now, with the 7, there's a question, could we make 7 a fraction? You can, but it's just going to be 7 over 1, right? X minus 2. What I would honestly say is you're just doing 7 times x minus 2. Do either of them have to be fractions? No, because they're just both over 1. You can make them fractions if you want, but it's not necessary. And then 10 over x minus 2, I'm going to multiply it by x minus 2. Now, here, I'm going to go back to making a fraction because there's another fraction. Okay? What happens on the left? X minus 2's cancel, and you have 5x. Now, what happens with 7 times x minus 2? Yeah, it doesn't, nothing cancels there, does it? It's a distribute. It's taking the 7 and it's distributing. So when we distribute the 7, it's going to become 7x minus 14. Plus, what about the end?
Just 10.
X minus 2's cancel, and we have 10. Okay. What are you doing? Okay, combine like terms. 5x equals 7x minus 4. Now what? Are we going to make this equation equal to 0?
Yeah.
You are?
No.
That's all.
Just find x, just solve for x.
Yeah. Do we have any x squareds? No. This is just put your x's on one side, numbers on the other side, and solve. So if I have 5x here, I would personally just subtract 7x. 5x minus 7x is negative 2x equals negative 4. And if negative 2x equals negative 4, what do you know? Divide by negative 2, and x is 2. Okay. What do we know about 2?
It doesn't work.
2 minus 2 makes my denominator equal to 0, doesn't it? So 2 doesn't work, so no solution. Okay. That can happen. It can happen. It did happen. Okay. Let's look at D. What about D?
Find the least common denominator.
Okay. And before we find that least common denominator, what do you notice?
You got a factor.
Yeah, x squared minus 9 factors, doesn't it?
Yep. Minus plus 3.
Yeah. X plus 3, x minus 3. If I've taught you anything this year, I feel like I've taught you factoring. Technically, Mrs. Rogers taught you factoring. Well, or
Mr. Weaver.
Mr. Weaver. However, I've reinforced it, yes? Because I don't know how much you guys remembered from Algebra 1, but. Okay. Coincidence that factors into the same pieces? Not really. Okay, what's my least common denominator?
X plus 3, X minus 3.
Okay. We have an x plus 3 in common. We have an x minus 3 in common. And any other leftover pieces? No. Okay. Have you gotten good enough? You're not writing it out, or are you still writing it out? Still writing it out? As I said, we can do your own thing. Up to you. So each piece is going to be multiplied by x plus 3, x minus 3. X plus 3, x minus 3. So I'm going to spread this out. X over x minus 3 plus 2x over x plus 3 equals 18 over x plus 3, x minus 3. So all I did is I rewrote the equation, leaving space to multiply each term. Each term gets multiplied by x plus 3, x minus 3. How are we going to make those fractions? Put them over 1. Okay, guys. Got everything ready to go. I wrote my equation. I wrote what I'm multiplying by. Let's see what remains when we're done. Okay, first piece, what cancels?
X minus 3.
X minus 3, leaving us with x and x plus 3. Plus, what about the next one?
Plus 3.
X plus 3's cancel, leaving us with
2x. And then parentheses x minus 3.
okay, 2x and x minus 3. On the right, what cancels?
Everything basically besides 18.
Okay. X plus 3, x minus 3's, we're left with 18. Next, you should, I've got to distribute first. X squared plus 3x plus 2x squared minus 6x equals 18. Combine like terms. So 1x squared plus 2x squared is 3x squared. 3x minus 6x minus 3x. And while I'm at it, that 18 is going to have to move over, isn't it? So subtract the 18 so I can set my equation equal to 0. Now, we're going to do this the easy way or the hard way? What's the easy way?
I think 3 goes into.
Yeah, you just factor out 3.
Can we factor out GCF of 3?
Yeah.
I would say slip and slide is the harder way here. Now, are we going to possibly get the same answers? I hope so.
Find out.
I hope so. I would say everybody divides by 3. So if I factor out a 3, I have x squared minus x minus 6. Yes? Then the 3, 2 parentheses, x squared is x times x, multiplying to be negative 6, adding to be negative 1.
Minus 3.
Minus 3 plus 2. Set each factor equal to 0. So I set x minus 3 and x plus 2 equals 0. What about this 3? Do I need to set it equal to 0? No, there's no x in it. 3 can't equal 0, so you don't have to worry about that. So x minus 3 equals 0, x plus 2 equals 0. What do I get as answers? Negative 2, positive 3. Are they working?
Not.
Okay. 3 doesn't work because 3 minus 3 is 0. So 3 doesn't work, and we're left with -2. -2 appears to be okay. Okay. Michaela, did you get the right answers?
Yep.
Okay. So, goes to show, slip and slide can work too. Just didn't need slip and slide that time. Is what it is. Okay. E and F? Let's get done. I agree.
No.
Okay.
He said E and F.
E and F.
She said
Not E and F.
Alright, let's
You're
go.
E and H, not E and F.
E and F.
Okay. E. Part E. Okay. Tell me what to do. LCD of?
X minus 3 and F.
The only denominator. So we're going to multiply everybody by x minus 3. Okay. I'm going to spread my equation out. X plus 6 over x minus 3 equals 2x over x minus 3. Every piece is getting multiplied by x minus 3. So that means x is getting multiplied by x minus 3. 6 over x minus 3 is getting multiplied by x minus 3. And 2x over x minus 3 is getting multiplied by x minus 3. Now, what about x times x minus 3? Yeah. It's just a distribute, yes?
Yeah.
X wasn't a fraction, so we just multiply. There's no canceling. So x squared minus 3x plus
6 is X minus 3 and X minus 3.
x minus 3's cancel, leave me with 6 equals
2X.
x minus 3's cancel, leave me with 2x.
Bring it over.
I see an x squared, so I want to make my equation equal to 0. So subtract 2x, and I have x squared minus 5x plus 6 equals 0.
X and X minus 3 minus. And then set them both equal to 0.
Okay, are you guys with us?
Yes.
Multiplying to be 6, adding to be -5 is -3 and 2. Set each factor equal to 0. X minus 3 equals 0. X minus 2 equals 0. We get solutions of?
2 and 3 can't work, so just 2.
Okay. 3 minus 3 would make my denominator equal to 0, so it's gone. 2 appears to still work. Okay. Last one. What are you guys going to do here? Okay, the only denominator is x plus 5. So we're going to multiply by x plus 5. Now, when we multiply by x plus 5, what we got?
Cancel. Cancel.
Squared.
X squared equals 25.
X plus 5.
So officially, if it's x squared equals 25, you can just square root. You could also make that equal to 0 and factor. Just saying. But I'm perfectly fine with what we're doing here. So, x equals,
Plus minus.
officially,
Oh my god.
I need to say plus or minus 5 because what am I doing? I'm taking a square root in an equation setting. So I always want to remind you of that. However,
And then you just take away the minus because
some of you are going to argue we didn't really need to say the minus, Mrs. Sargent, because
it just goes.
it doesn't work. -5 plus 5 doesn't work. So I get it. However, it's a good opportunity for me to remind you, don't forget the plus or minus, because it can matter at times.
So does it
Okay.
work?
Huh?
So does it work?
5 works, -5 does not,
It's -5.
because -5 plus 5 would give you 0. Okay, guys, your homework is lesson 4.5. I think there's 10 questions.
That's a lot.
I get it.
So-
They don't flex.
And keep in mind, you can do the questions faster on your own probably than I can, you know. Because I can go through them pretty quickly on my own if I'm not leading a class. So.
I can't believe the last class we got to.